Hello, my name is Dr. Beth Cudney, and in this video I'd like to take you through the concept of single-minute exchange of dyes, which is also commonly referred to as SMED. And it's a technique that focuses on reducing the changeover time for your operations. What we're trying to accomplish with a quick changeover is to reduce the setup time it takes on any piece of equipment within operations. With this, what we're trying to do is get down into the single digits of time when we talk about single minute exchange of dyes. So if you think about a single minute or a single digit, that's 9 minutes or less. We're trying to take changeover times that are often 4 hours, 5 hours, or longer and reduce those down to the single digits. So we could think about examples of changing a tire on our car, and the difference with a changeover time of 5 to 10 seconds if we think about pit crews. SMED was developed by Shigeo Shingo at Mazda, Mitsubishi, and Toyota in the 1950s and 1960s. Shingo spent 19 years observing different setup operations in various factories. The methodology was initially developed to improve die press and machine tool setups. These setups often took multiple hours, typically 6 to 8 hours, and the goal was to reduce this to a much shorter time in order to increase the number of changeovers and run products more frequently. SMED is a key concept in lean operations because oftentimes the mindset is such that we don't want to change over and run a new product because a changeover takes too long. However, we can reduce that changeover to a much smaller time and down to minutes. Then we can change over and run products more frequently. And by running products more frequently, we can hold less inventory on hand. Another key aspect of this is that we can meet customer demands quicker. For example, if a customer calls and they change their order today for what they want delivered tomorrow or the next day, we can change over quickly in a more timely fashion. There are two key points with SMED. The first is that setup operations can be divided into two categories: internal setup and external setup. Now, while SMED started in more the manufacturing environment, it's also applicable in healthcare and other industries. When we think about SMED, it's probably easiest to first think about it in terms of manufacturing. With internal setup, these are changeover operations that are internal to the machine. What this means is, in order to make changes internal to the machine has to be off so that you can change over safely. External setup are all of those operations for changeover that can be done outside of the machine. For example, you can get all of the tools and equipment ready before you shut down the machine. If we think about this in other industries such as healthcare, if we're changing over an operating room, there are certain things that we can have prepared outside of the machine, such as all of the instruments for the next procedure. These can be done externally. When we talk about cleaning the operating room to prepare it for the next patient, those are all done internal to the operating room. Now, if we think about the common mindset within manufacturing, if a machine is down or a resource such as an operating room is not being utilized, then we're wasting resources. Now, on the flip side, we also want to make sure that we're not overproducing, which is another waste within lean. This leads us to the second main point with SMED. Converting internal setups to external setups can substantially reduce the changeover times. If we can have all of the equipment and fixtures ready to go before we shut down the machine, then we're reducing the time that the machine is shut down and we're not producing products. And so we want to convert as much of the internal time to external time. It's important as we're analyzing our process to really understand the difference between the internal setup and the external setup. Internal setups are performed when the machine is not operating or when the operating room is not being used. And external setups are performed while the machine is running. In terms of healthcare, This would be setting up for the next procedure while the current procedure is finishing up. And so by converting our internal setups to external setups, we're reducing that overall changeover time, which increases the time that machines can operate or resources can be utilized. Now, another key aspect is when we look at our changeover time, our total changeover time is captured from the last good piece of one product to the first good piece of the next product. And any time between that is time that's lost. It's wasted time. This changeover time consists of, as soon as the machine stops, to pulling out fixtures, equipment, running sample parts, inspecting those sample parts, making adjustments and tweaking the process as needed, and then re-inspecting parts until the process is finally able to produce a good part. The goal then is to reduce that overall changeover time. There are 4 key stages with SMED. The first is to document the current operations. One best practice would be to videotape the current operations so that you can get a detailed analysis of all of the steps and how long each of those steps takes. The next step is to separate the internal and external setup time. And we can do that by simply using a chart that documents each step and then labeling each step as internal or external. The second step then is to convert as many internal setup times to external setup times as possible. Then the final step is to streamline the setup operations. In documenting the process for SMED, a simple chart referred to as the setup analysis chart can be used to document and analyze the process. In the header of the chart, we're capturing information on what machine is being analyzed, what product is currently being run, and what product you're changing over to. And then each step is numbered and each changeover element is recorded. And then the time for that changeover element is recorded, and then it's captured by each of the changeover categories, which include internal, external, and waste. Based on the categories, we can include the improvement plan and then the goal of the improvement plan, whether it's to eliminate that aspect, change it from an internal to an external setup, or to reduce that time. For example, the first step is to remove the fixture. This would occur when you have to change the fixture for one part to the next part. This changeover element currently takes 12 minutes, and all 12 minutes of this element are internal time. The improvement plan from the team is to eliminate the bolts and install quick releases. And therefore, the goal of improvement for this changeover element would be to reduce the time from the 12 minutes. Another example would be step 2, in which the team searches for tools. This currently takes 8 minutes, and this time is all waste. Therefore, the improvement plan would be to mount the necessary tools at the machine to avoid searching for the tools. And the improvement plan then would be to eliminate this time. Using this information, the team could also do a Pareto analysis based on the major categories. And in this example, the major categories were fixture change, tool change, search time, and the first piece. As a side note, the first piece typically refers to the first part that's run through the process that's used for 100% inspection to ensure the changed over process is making good parts. The Pareto chart shows where a majority of the time is being spent, and in this example, the majority of the time is spent with the fixture change. In order to reduce the changeover time, effort should focus on the fixture change. I hope you've enjoyed this video on single-minute exchange of dies, and I wish you the best of luck on reducing your changeover times in your process operations.